we have this function here to find the Laplace transform. F of t is equal to 2t, 2 sine 3t plus cos 3t. Now, let's expand the brackets and write it as f of t equals 2 e to the 2t sine 3t plus e to the 2t cos 3t. Now, here, we're going to have, we know that when we have e to the power of a number times t, we're going to apply this first shift theorem. Let's look at our formula sheet and see what it looks like. You see, when you have t to the n, or when you have 1, I mean 1, the Laplace transform of 1 is 1 over s. If it was 2, the Laplace transform would be 2 over s and so on. But look at this. 1 by e to the at is 1 over s minus a. Alright? Let's also look at the sine. Sine at is a over s squared plus a squared. But e to the at sine, well, this should have been bt. It would be, in this case, it should have been b at the top here, not a. Alright? It would be b over, instead of s squared, you replace s squared with s minus a squared. And when you look at cosine, cosine at is s over s squared plus a squared. Now, when you have e to the at times cosine, is going to be s over, so you replace s with s minus whatever multiplies t squared plus b squared. Look back at sine, you replace s with, instead of s squared you're going to have, you replace s with s minus e to the number multiplied by t. So you replace s with a. Alright? Now, it means when it comes to the Laplace transform, and you have e to the at times f of t, then f of s is going to change, or let me write it this way. If you have the Laplace transform of this, is going to be f of s minus a. Right? If you didn't have that, and you have the Laplace transform of f of t, what you get is f of s. But when you have e to the at multiplying it, what you get is f of s minus a. So let's apply that to what we have. Now f of s is going to be, now here is 2 times, now the Laplace transform of sine 3t is, now for sine at is a over s squared plus a squared. So for sine 3t is 3 over s squared plus 3 squared. But guess what now? If you multiply this by at, instead of s squared, it's going to be s minus a squared. So it's s minus a squared. And now plus, look at the Laplace transform of cos AT is s over s squared plus a squared. For 3t is s over s squared plus 3 squared. But now note you have multiplied by e to the 2t, so that's going to make a change here. You have s minus the number that multiplies t there in the power. So it's s minus 2. Oh, s minus 2 squared. It should be. No. I just realized I had left this as a. It should be s minus the number that multiplies t in the power of at. So it's 2t, so it's 2. If this was e to the 3t, this would be s minus 3. And so on and so forth. If this was e to the 4t, this would be s minus 4, and this would be s minus 4 here. Alright? Or it's e to the 2t, so it's s minus 2 that you replace it with. The first shift theorem you apply here. Alright? So what you have here is 236 over s minus 2 squared is s minus 2 by s minus 2 plus 3 squared, which is 9, plus s minus 2 divided by s minus 2 squared, which is s minus 2 by s minus 2 plus 9. So that is f of s. So f of s is 6 divided by, if you multiply out the brackets, you have s squared minus 2s, which is minus 4s. Minus 2 by minus 2 is plus 4. Plus 9. 9 and 4 is what? 13. So this would be plus 13. And then for this now, you have s minus 2 over, well, it's the same thing you're going to end up with here. S squared minus 4s plus 13. Okay. So here, you can just write everything as 6 plus s minus 2. That's going to be s minus 2 plus 6 is what? 4. S plus 4 divided by s squared minus 4s plus 13.